So we're still pre-live.
Hey, good afternoon, everyone. My name is Dave Schulteis, and on behalf of San Francisco Train and Specialty AC Products, welcome. I want to thank everybody for taking time out of your busy schedule to be with us today. We hope that the next hour and 15 minutes or so is well worth your time. We've done our best to present some really great information for you today. During today's Indoor Environmental Quality COVID-19 Symposium, we're going to look at the 4 best technologies out there for COVID-19 mitigation. We all know how difficult the past 12 months have been, but as the economy is rebounding and businesses are starting to open, people are getting back into offices and into places of business, decisions need to be made. Decisions about how to best protect our employees and our customers. Decisions about how we're going to deal with the end of this pandemic and how we're going to prepare ourselves for the next pandemic. Decisions that can now be made with the availability of federal stimulus funding. And I want to emphasize that last point. As a building owner, you're not on your own here. There is federal stimulus money out there to help with these costs for all these technologies that we're talking about today. Next, I'd like to thank the 4 presenters we have today, our 4 manufacturers. Dynamic Air Quality Solutions, Genesis Air, Integrated Viral Protection, and Plasma Air. So today we're going to learn about high efficiency electronic air cleaners. We're going to learn about photocatalytic oxidation, biodefense air systems, and bipolar ionization. Before we get started, just got a quick bit of housekeeping to take care of. Everyone's microphones and cameras have been turned off. So the only way for you to communicate with us today during this symposium is through the Q&A section. So somewhere in the upper right-hand corner of Microsoft Teams, there should be a little question button. That's the Q&A section. So as questions come up, please type them into the Q&A section. The format we're going to use today is that each manufacturer, each speaker is going to present for 15 minutes. And at the end of those 15 minutes, we'll set aside 5 minutes for Q&A. So as they're speaking, please use the Q&A section to ask questions. And when each speaker is done, we will get as many questions in the 5 minutes as we can. So with that, I would like to turn it over to our first speaker today. Our first speaker is from Dynamic Air Quality Solution. Duke Weiser is the president and CEO of Dynamic, and here is Duke.
Dave, thank you. Thanks for putting this together. I think it'll be an interesting presentation and a good group of companies. So I guess first slide, if we can. We've been making air quality systems to remove particles, biologicals, gas phase contaminants from airstreams for a variety of applications for a long time. I guess the commonality is we try and do that by also using a lot less energy and have a longer maintenance cycle. So in the normal times, on new construction, we're replacing high efficiency passive filters, and the deliverable is less energy, better ROI, less maintenance, etc. We do a lot of energy and filtration retrofits and upgrades. So for people that already have high efficiency filtration, we're going in as a CRM to reduce the energy footprint. For example, we did all the federal buildings in New York City with Train out in New York, or we'll help people upgrade their filtration where they don't have a lot of fan horsepower to put in a high efficiency passive filter. And the third type we do is fix problems, very specific problems, but I guess that's where COVID fits in. So a few, sorry, Brian, next slide. Just touching briefly on what we're dealing with here. And I'm sure a lot of you have read about it in terms of the actual physicality of it. So really, the important thing to remember is the thing that is novel about coronavirus is not that it can somehow magically evade filters and things. It's that people have no immunity to it. And so the novel thing about it is the way it interacts with people.
Sorry,
in terms
Duke,
of the way,
it sounds like no one can hear anything.
about now?
No, not with you or Dave.
Okay.
No one has been able to hear anything.
Anything so far to date? So, no. So what do we want to do about that?
I'm trying to figure out why.
I can hear here. This is Brian.
So maybe we can all
Yeah,
hear.
we can hear as presenters, but he's not.
Okay.
This is Dan. I can hear as well.
Well, do you want to buy some air cleaners? No.
Sure.
All right. So I guess we are just on hold until we figure that out. Yeah, there's no.
You got any finger puppet magic there, Duke?
Okay, I have you on live.
Brian, can you hear me?
Yeah.
Hey, Brian, a bunch of people are posting in the Q&A section that they can hear.
Yeah, we
Oh.
know.
Okay.
I think, yeah. No, and they can't. They didn't hear you either, apparently.
Yeah. So let me jump in and we'll just start over, Duke.
Did we think we fixed it?
I don't know why others couldn't, but sure, let's just keep going.
No,
Sorry
Brian,
about
why don't we start over?
Okay. Can't hear you.
Dave, I think you're muted.
Hey, everybody. It looks like we had some technical difficulty. Some people said they couldn't hear, but I believe we have it fixed. We're just going to restart here. I'm Dave Schulteis, and on behalf of Specialty AC Products and San Francisco Train, welcome. Today's presentation, we're going to talk about indoor environmental quality, COVID-19 solutions. Over the past 12 months, things have been difficult, but as the economy is rebounding and people are getting back to business and back to offices, decisions need to be made. Decisions need to be made about how to best protect employees and customers. Decisions need to be made about how we deal with the end of this pandemic and how we're going to protect ourselves from the next pandemic, and decisions that can now be made with the availability of federal stimulus funding. So I want to emphasize that point, that there is federal stimulus funding out there for all of these technologies that we're going to talk about today. A quick bit of housekeeping. Everyone's microphone should be off. The only way for you to communicate with us today is through the Q&A section. In the upper right-hand corner of Teams should be a little question mark where you can post questions. Each speaker is going to speak for about 15 minutes, and then we'll do 5 minutes of Q&A. So if you could post your questions in that section, we'll get questions into each speaker at the end of their turn. Okay, with that, I'd like to turn it over to our first speaker today from Dynamic Air Quality Solutions is the President and CEO of Dynamic, Duke Weiser.
Dave, thanks for that, and thanks for hosting this. I think it'll be an interesting group of presentations of some complementary technologies. For our standpoint, at Dynamic, we have been making things that remove particles, biologicals, and gas phase contaminants from the air for a few decades now. The one commonality is we try and do those things by having less of an environmental impact, less fan horsepower, less energy, and less maintenance. And so normally we're replacing a new construction, high efficiency passive filtration with our systems, and the deliverable is less fan horsepower, less energy, and a much longer maintenance cycle. We do projects where we are retrofitting either as a part of an ECM energy retrofit or filtration upgrade into existing buildings that may have high efficiency filtration, in which case we're giving them, again, a lot less energy and a lot less maintenance. You know, for example, we did all of the federal buildings in New York City with a train out there. And then we're doing projects where there's a specific issue that we're trying to resolve, and I guess that's where COVID fits in, and that's really what everybody wants to talk about now. So just briefly on what it is that we're dealing with, right? And so the novel thing about coronavirus is the way it interacts with people, right? People have no immunity to it, and that's sort of its superpower. But in terms of how it deals with and interacts with filters and UV lights and disinfectants, etc., it's just like any other virus. It can be caught on a filter, killed with a UV lamp. It'll die by itself after a few days. So next one. So the airborne transmission is probably the key vector of transmission here. And that's partly because of the size we're dealing with. So the coronavirus itself is quite small. It's 0.15 micron, as are most viruses. But a virus never travels alone. It always travels in a little packet of moisture that you have coughed, sneezed, talked out. And those can range from a little over half a micron on up, depending upon whether you're sneezing or talking. The key size range to deal with, where most of it is generated and is in the 1 to 3 micron range. Also, those particles stay suspended long enough that they're going to interact with other people and with the HVAC system. So I won't read all of these, but the common thread here is that, you know, indoor events tend to be where the super spreading events are. And the most interesting one to me is the third one down, which is a Korean office building that had a call center where half the people on that floor got sick, but only 3 people in the whole rest of the building got sick, even though they were sharing doorknobs and elevator buttons, etc. So the key thing there is that it is airborne transmission is real and is something that we need to deal with. And obviously there's personal protection, but beyond that, the HVAC system plays a role. Interestingly, we're not starting from scratch here. I mean, ASHRAE and others had done a ton of research in the wake of SARS and MERS and H1N1. So they knew how this stuff travels around to space, how viral particles travel in a building. And they came out way before, you know, while a lot of regulatory or governmental agencies around the world were still sort of hemming and hawing about airborne transmission. Yes, it is. It's going to happen, and there are things you can do to make it better. So ASHRAE's recommendations, which you've probably seen, are, you know, improve your filtration efficiency, ideally to MERV 13 or better in your central systems. Use germicidal UVC where you can in those same systems. Supplement if needed. If you can't upgrade your filtration, or you don't have many air changes, or you don't have any air changes, put in, you know, supplemental air cleaning systems that will move and clean the air in a given space. Increase the ventilation rate to the extent possible, on the theory that outdoor air is relatively corona-free, and therefore by exhausting indoor air and replacing it with that's as good as filtration. And then also looking at other things like airflow patterns, pressurization, and humidity levels in the spaces. This filter and this slide I stole from an ASHRAE presentation, full disclosure. But what it shows is how you can reduce risk of infection by increasing filtration efficiency and/or by bringing in more outdoor air. And so if you look at the little black squiggle, it shows that going to MERV 13 is far and away the biggest bang for your buck. Even going to HEPA filter doesn't give you a huge benefit, and it has a huge energy penalty. Similarly, if you look at ventilating instead of filtering, you can do it, and you can get to those same risk levels, but it's at a pretty significant cost because all that outdoor air has to be conditioned. So I don't think in general that this isn't an either or. It should be a both and, but that just gives you an idea of the relative costs there. So drilling down on that filtration piece, filters in North America are rated by the ASHRAE 52.2 standard, which gives them a MERV rating, which is minimum efficiency rating value. That's what MERV stands for. And it's really, again, aimed at comparing passive filtration devices, so filters. And long story short, or in brief, a passive filter is essentially a sieve, and so your trade-off, and this is an oversimplification, but the trade-off is pressure drop for efficiency. So the more efficient it is, the harder it is to push air through it, and therefore the more energy you use. And in general, 90% of the cost of filtration is energy. It's not the cost of the device, it's the cost of the energy to push air through the device. So what does a MERV 13 mean? Well, the ASHRAE, the test measures particles with laser particle counters upstream, downstream, and measures them between 0.3 microns and 10 microns. And a micron is a 25,000th of an inch. It's sort of how we measure stuff in the air. So it takes readings upstream, downstream, and in between those readings, it loads the filter with a artificial loading dust that is highly conductive, that is a little bit of an anachronism, but it is still the dust, even though it's not used anywhere else in the world. That said, so what it does is it takes your worst performance in each size category, averages those together, and it gives you your efficiency. So if you look at that chart and go down to the line 13, a MERV 13 filter is more than 50% efficient in the 0.3 to 1 micron. It's more than 85% efficient in the 1 to 3 micron range, and it's more than 90% efficient in the 3 to 10 micron range. The dynamic V8, which is what we would use in a MERV 13 or greater situation, would have less static pressure and a far lower energy consumption than a MERV 13 filter. We're going to be 99% efficient in that critical 1 to 3 micron range. So again, since this is our Reader's Digest version, and we only get 15 minutes of fame today, I won't go into the extended details, but in essence, we are combining elements of passive filtration and electronic filtration, electrostatic attraction. So we have an active field as well as a media. So the media collects particles and loads more readily and more uniformly than a passive media would. And that's sort of what gives us our ability to outperform a straight passive filter. And so looking again at that V8, which again is our sort of what we put in labs and museums and universities and hospitals, etc. In a standard MERV test, it's MERV 13 and 14 versions. If you do the same test without the conductive dust, which is the way all other tests are done, it's MERV 15 plus. It's also able, because of the various mechanisms, to take out the stuff that the MERV test doesn't even look at, so the stuff that's smaller than 1/10 of a micron. Another critical thing is it has a zero bypass seal, meaning that everything goes through the media. Because and that's critical, because if you've got, the HEPA filter standard, for example, is as much about seal as it is about media efficiency. Because if you've got HEPA filters and you've got a gap this big, you don't have HEPA filters. So seal is important from a performance standpoint. We're also able to take out moderate levels of VOCs, sort of low nuisance levels. We make carbon systems. We can, for industrial settings, but typically people don't want those. This has a 10x dust holding capacity versus passive filtration, which yields typically a 3 to 5 year maintenance cycle. In addition to that system, we have glass media using the same underlying technology. And in many cases, we're coupling that with high output 254 nanometer UVC, which again will inactivate any biological, including coronavirus. The good news about COVID, for example, is it's actually relatively at the low end of the scale in terms of how much radiation it takes to do that. And we'll use these systems in hospitals, etc. We also have panel air cleaners, 1 and 2 inch panel air cleaners that can go into smaller equipment, fan coils, fan powered VAVs, etc. And we have a range of sort of stick anywhere UVC options that can go with those products, so that you can take advantage of the catch, hold, kill performance. So this is a chart that looks at particle counts at 0.3 micron in a recirculating system. So air changes on the bottom, particle counts on the left, and we do a better job, right? So it looks at MERV 13 and 14 filters. Obviously the V8 is doing a better job more quickly than those products. This is loading as a function of dust held and pressure drop. And so, various passive alternatives will hold a few hundred grams of dust. The V8 in contrast will hold, several thousand grams. And that's what gives us our energy and maintenance advantages. This is looking at TVOCs, upstream, downstream. Again, these are fairly moderate levels, nuisance levels that you would find sometimes in a building, and this is coming specifically from exhaust systems. I mean, from auto exhaust, excuse me. And this was over a long period where we had a fair amount of a nice reduction. We do, again, make carbon systems, so that's a variation, but certainly not germane to COVID. And then, so recapping on the V8, MERV 13 to 15 performance, a third the operating cost of passive filters in that range, far less maintenance, the ability to take out the ultrafine particles. And that's important in an urban setting because that's most of what's in the air. And in any kind of urban setting, the primary source of ultrafine particles is vehicle, kitchen, other diesel generators, some sort of a combustion product, forest fires. A significant reduction of VOCs and odors, typically no pre-filters, much lower design mid-life, typically an inch of static less than a standard passive array, less cost of ownership, and a pretty decent ROI. Looking again at the combination of the UVC and the glass media, sort of for catch, hold, kill, those get used, historically those have been used in sort of niche applications, food processing, and places where people are concerned about airborne biologicals. Of course, everybody is at this point. But what this shows is that UVC requires a certain dose to inactivate stuff, and so that's a function of intensity and time. And so by capturing the pathogens on a translucent surface, we're able to take our time and inactivate them. So in terms of, I'm going to conclude so gee, you do all this stuff for coronavirus, and what is that? Is it just an ongoing cost? You rip it all out? And I would say it's an ongoing savings, and you don't rip it out. So a lot of the energy that is spent in a building is related to HVAC, and a lot of that is related to fan. And so things that can significantly impact fan energy can have real carbon footprint diminishing abilities on the overall building. And maintenance, of course, is always an issue. But the other thing is, this is a justification. There's a quick payback on just that type of stuff. But really, that pie is a teeny sliver of what you spend money on in a building, and that's people. Most of what you spend money on in a building is people, and that's the whole reason you have a building. And so you can just scroll through the things. And so basically, if you sort of do the math on filtration upgrades and increasing, and there's been a proven again and again correlation between filtration or air quality upgrades and increasing productivity. So looking at these slides, it doesn't really take much of an increase in productivity to pay for an air cleaning system. The last one. So I guess this is conclude with this is, I think the changes that we are seeing here or the upgrades that people are going to be looking for are going to be an ongoing thing. I mean, and it's just accelerated what's already been happening in the industry and with expectations around air quality. I mean, you think 25 years ago you could smoke in a building, right? And then with LEED and well buildings and other standards that really focus on air quality, people expect that their air is clean. They don't always know what that means because clean air is, you can't see it. But now they kind of do. Now they have another thing to add into that. It's like, oh yeah, I want air that doesn't have any viruses in it. So I think it's going to change the expectations around what people want in their buildings and demand in their buildings. That's all I've got. Thank you so much for your attention. And I'm happy to take some questions if there's time, although I know we got off to a later start.
Thank you, Duke. Appreciate it. Yeah, a couple of questions did come in. A gentleman by the name of John Lee had two questions. I'll actually take the first one. Are V8 available in any OEM units? And the answer to that is yes. The dynamic V8 product can be installed in Trane air handlers, Trane package rooftop units, custom air handlers, lots of different options for where dynamic V8 can be installed. He also asked, Duke, this is for you. Do you have any UL ETL rating with HVAC for the product? Yes.
Yeah, you have to. So we have UL 867, we have UL 508 for all the control panels. We're a 508 shop. We've got 2998 for ozone production, all that good stuff.
Okay. One last question then. This came in anonymously. Please comment on V8 and OSHPD approval.
Yes, we have that as well.
Perfect. Good. There is another anonymous question that came in. Someone asked, how can we real-time monitor the performance in the spaces? Actually, we'll hit that at the very end of this presentation. But there are options out there for monitoring what's going on in the space through building automation systems, and Trane has some good solutions out there. We'll come back to that question.
Okay.
Okay, Brian, if you could move on to the next slide. Up next is Genesis Air, presented by Dan Briggs, the president of Genesis.
Good afternoon, everyone. I'll do a quick product update. For those of you who don't know what photocatalytic oxidation is, I'll briefly explain that. It's all centers on an oxidation reduction reaction. So really, when you think of photocatalytics, think of the catalyst on your car. That's a thermal catalyst. We're using the energy off a UV lamp instead of the heat off an engine to create those free radicals. So our product primarily deals with first pass destruction of biologics and VOCs. We have introduced, and we're currently having single pass testing done by University of Texas Medical Branch. And with COVID-19, I'm also taking equipment as soon as this is over from Lubbock, Texas to the University of Oregon, where we're doing testing in room where we know we have COVID-19. So Specialty AC and Trane will have the results of those, and a paper apparently is being written where it'll be peer reviewed. One of the reasons that's probably as important is because there's so many products out there right now that are not legacy technologies, and nearly all of them center around the creation of free radicals. So our product is a little different than some of the others, maybe even some that'll be presented later, in that the free radical we create has a half-life of a billionth of a second. So we go all the way across the airstream. Whatever we do in a single pass. It was mentioned before that VOCs are important. Our single pass VOC, we've done a lot of grow houses of late. Single pass VOC, where you have concentrations of 1 to 15 parts per million, is about 90% reduction in a single pass. So we do have some good VOC information. We do have a lot of extensive third-party testing. It was done about 15 years ago, so we've started upgrading. Our product has been value engineered traditionally out a lot of jobs, and particularly offices and things like that. But now indoor air quality, of course, has a much greater emphasis. And for example, our little company, we've been in business 20 years, has grown about 8 times versus our best year ever prior to this in the preceding 20 years. So air quality is something that obviously is on the mind of those of you who are watching this. Our panels themselves, there's a picture in the bottom right. It looks like a really poorly pleated filter that somebody's painted white and hadn't painted over the holes. That's because, number one, we're not a filter. We need a product like the previous presenters ahead of us. We don't want to capture anything. Same thing, same principle as an evap coil. Because we're doing energy transfer on that panel, we want to try to keep it clean. The panel itself also, that's not a nice, clean, crisp pleat. We don't want that. We want the air bouncing around in there, where our chance of single pass reaction is greater. On the left is a picture of an old train unit. One of the things that we are is a factory standard option. The last year, we've probably done a significant number of those in their performance climate changers, their custom products. And now we are going more and more into the rooftop units, the Voyager, IPAC 1 and IPAC 2. Primarily, we're doing retrofit at this time, but we've done it in a number of new applications that are coming up. So you can field install the panels. One of the nice things about them is they take very little space. Side load in the train unit only takes 6 inches. A front load in an air handler only takes 13 inches. Static pressure drop is 0.05 at 500 feet per minute. Takes minimal energy use. And we're really looking forward to the in the room unit. We're going to have 4 different models of those, but we're going to undergo some pretty extensive testing and actually use the SARS-CoV-2 virus because we've been fortunate enough to be allowed and get involved in some research programs. So as we move on, what our product is we've incorporated it into a hospital or 2, about 140 in fact, as part of an overall infection control plan. So you do all the things that you normally do. One of the problems CDC and WHO had was they always in the past have said most infection transmission is person to person from surface to wound. They don't really have a method of dealing with something now, and as Duke pointed out, airborne transmission is very definitely a part of the SARS-CoV-2, and our products work really well with dealing with destroying them. We don't capture anything. Now we do have typically, whenever we can, a MERV 13 filter upstream, but our products have gone in with units that are basically I don't know, a MERV nothing that you bought at the grocery store. We still have the ability to destroy on the fly in a single pass. So on the bottom right is a picture of a train performance climate changer where you can see a side load panel there on the right-hand side with the blue. And then in the left is a picture of a unit at San Francisco Airport where it has been retrofitted into a new unit of a different brand. So it's a real flexible product, but I want you to be aware all we are is a part of a comprehensive program. We're certainly not the be-all end-all solution. It has to be incorporated with other common sense things. But the panels themselves are fairly cost effective as far as your rate of return on investment, because they last for 15 years of continuous usage. So as we move on to the what is the product, here are a couple of pictures. On the left, you can see that it looks like a filter that's been painted white when the lights are not on. When the lamps come on, it's illuminated all the way across the airstream. When it is illuminated, it is creating a free radical. One of the things that's important about our product is the free radical we create does not migrate out into the occupied space. The half-life on the hydroxyl radical is less than a billionth of a second. So when it goes from the white panel on the left to the blue panel on the right, that is an instantaneous reaction. It's all the way across the airstream, which is why we have first pass efficiency. But when the light goes off, it instantly goes back to the white panel on the left, and there is no more creation of the hydroxyl. And with the hydroxyl's half-life, it's not really migrating more than less than an inch, less than a half an inch off the panel, even at 500 feet per minute. That's one other thing to be aware of. All of our third-party testing was done at 500 feet per minute. So we match normal industry standards. And the panel itself, here is kind of how it is distinctive. There are a number of PCO products on the market. Most of them have a honeycomb, and some of them have to have downstream carbon because they create intermediaries with UVC. One of the reasons we've done third-party testing using a typical office mix that was formulated at Lawrence Berkeley, and we don't create the secondary or the daughter intermediaries in a rate that is of any concern, but that testing is available through Train. But the way the panel works is the energy from the UV lamp, as you can see, the little blue tube going through, is all the way across the panel. That separates us from other PCO products in that ours has complete energy distribution. And then on the bottom right, it shows that the location of the reaction is in what in the previous picture, that white filter looking thing. Well, the energy runs through the middle of it. So we create these free radicals both upstream and downstream. So we get really good single pass efficacy. We're doing a dual contaminant control. We're doing VOCs and we're doing bioaerosols. We have the current rate of bioaerosol reduction using MS2, which is up to this point, before the arrival of COVID-19, was a standard way to test for efficacy with viruses because they're extremely difficult to detect. But most end users want to know what it's actually doing with COVID-19. The things we've tested with, according to the healthcare experts, are actually more difficult to kill than COVID-19. We're doing the test to find out, just to make sure that we don't overpromise and underperform. The panel itself is easy to install across an airstream. As I said, basically you build what looks like a filter rack, and you can either front load or side load them. And as you look at it, what's happening in that panel is an oxidation reduction reaction. It's a very natural process. It's passive in a sense that we do not broadcast anything down the airstream, and the reaction does not occur out in the air where the people are. And so it gives us a level of confidence that long term there won't be some situation that occurs to us that happened to Sharper Image, where you go from 42 million a year in sales to 0 in 2 years because you found there was an unexpected byproduct that you were producing. So we're pretty cautious, and we don't make an awful lot of claims, but we have done enough third-party testing by the Department of Defense and by Homeland Security to know that with bioaerosols, this product does a really good job in a single pass. It doesn't have to happen over time. We do it right now. And so as we go on to kind of give you a summary of the advantages, it's safe for occupied spaces. We're in over 140 hospitals. We've done a very good job of reducing the standard infection ratio. Center for Medicare Medicaid has released data on hospitals now since 2015, and hospitals that have our product in their critical care areas have a 20 to 40% reduction in the number of cases of MRSA. So that does point out that even though MRSA is not considered something that's an airborne contaminant, there must be an airborne component, and we've shown those numbers from 2015 until now. So that information is available as well. We do not create free radicals in an occupied space, and you can Google the internet and find out all you want about free radicals. We do have a single pass reduction. We do help safeguard, but remember, only when we're incorporated into an overall infection control plan. The panel themselves is effective in reducing TVOCs and bioaerosols. It takes very little energy cost. One of the things to be aware of is our static pressure, again, is only 0.05 at 500 feet per minute. Our maintenance cycle is a long one. The panels are designed to last 15 years. The maintenance is the lamp itself, the energy source, is designed to last for 12,000 hours, which is about 15 months. However, end users do their budgets annually, so it's just an annual replacement. The units are really simple to retrofit in most HVAC systems, air handlers, RTUs. Through Train, you can get curb options. You can get options that go in supply ducts. You can get them, of course, in the unit. And now we're going to have a full line of units that will be used within the space. For example, in dorm rooms, hospital rooms, nursing homes. We've done, our largest customer is the largest employer in the state of Oklahoma, and they have about 200 buildings to 300, depending on whether it's owned by the Native American group itself or whether it's one of their various companies they own. But they're retrofitting all their products. I think they did some extensive research on what was the easiest way to go, because our product will reduce VOCs. We went into their casinos and we went into their child care centers for completely different reasons. But I just want you to be aware the panel and the product has a number of usage. It's not limited. And as we get ready to close here, I'll just quickly review. It destroys, it doesn't capture. The reaction is safe because it occurs in the panel. We create free radicals, which is the basis of most new technologies. You're creating an oxidizing agent that does an oxidation reduction reaction. So you probably need to be aware of where that's happening. The energy for ours is a UV lamp, and that is germicidal. So when you put it in an air handler, if you can position it, and it can go in the saturated zone, where it shines on the surface of the coil, will keep your coils clean, will lower your TVOC count, and will reduce your bioaerosols. So low pressure drop, it's pretty easy to service, doesn't require much space, it has very low energy. The energy is 0.05 kW per square foot, and that is across the cross section of the ductwork, not per square foot of the space. Front loads take 13 inches, side loads take 6. It can go in new systems. It can be retrofitted into old. We have air handling, we have RTUs, we have duct mounted, and we've been very, very successful in the last several months with helping give our end users a degree of confidence when it comes to dealing with an airborne virus that's very, very contagious. One thing I'll close with is we, like an evap coil, need good upstream filtration. So remember, we don't take the place of filters. We are a complement, or we complement them, and we offer a really good single pass efficiency with the technology that's been on the market now for about 20 years. And this is just a lineup of what we're offering this spring. We have a new group of duct-mounted offices or duct-mounted systems that are probably our most cost-effective per CFM units. We have a roll-around unit that can be ducted down there in the bottom right. We've sold a number of systems for RTUs where they're fitting in curb adapters. And then we have the ducted unit on the bottom left that will recirculate, and it can do 2 or 3 offices at once with the filter grill and some supply duct added to it. And then our newest unit in the upper left is a unit designed to do about 1,400 square feet, but we will have about 4 units that we'll offer as soon as we finish the UL. Oh, by the way, all of our equipment is OSHPOD and is UL because we're a trained source product. We have all of the certifications that you would normally expect to meet their legal criteria. And I think that's about it. Do we have another slide perhaps for me to say goodbye to everyone? Yeah, the use of the panel is to deal with airborne or bioaerosols, the small guys, to break down hydrocarbon chains and to keep the surfaces that are being shined on inside the unit. And then we'll close with third-party testing. We've been tested by the Department of Defense at their weapons lab in Dugway, Utah. This last year, we were tested at LMS Technologies using a mini Pleat MERV 13 in our equipment with a background of over 20,000 colony forming units per cubic liter at 500 feet per minute. We were able to reduce the viral substitute MS2 by 99.4% in a single pass. We've been tested with an airborne virus at Iowa State University. We've also done extensive third-party testing at Research Triangle Institute. For any questions you have about our testing, that's available from your train office. And I think we'll simply close with this. Dave, do you have any questions for me?
Dan, there were a bunch of questions that came in while you were talking, and you actually answered all of them. The last one that came in was regarding MS2 measurements, questions about UL. You hit all the questions that came in.
Well, I got the cheat. You did a good job before me, so I knew what to hit.
Great. All right. Thank you, Dan. Okay, up next we have Integrated Viral Protection presented by Brian Paytek, who is the COO of IVP. With that, here's Brian.
Hello, and thank you for your time today. And we'll go ahead and kick this off. The Integrated Viral Protection Air Biodefense System was invented and developed by Manzar Hirani, who is a medical developer, develops hospitals and medical buildings across the country and across the globe. Next.
The deadly COVID-19 pandemic has impacted the globe. Airborne pathogens like SARS-CoV-2 can survive in the air we breathe for hours. So virus-fighting technologies must be implemented quickly to stop its spread and prevent future pandemics. A recent innovation by Manzar Hirani and a team of Texas scientists can kill the novel coronavirus with a specialized heated filter made from a high-performance metal foam. The filter's high temperatures instantaneously eliminate the pathogen without significantly heating the ambient air. Researchers at the Galveston National Lab have demonstrated that SARS-CoV-2 and anthrax spores can be vaporized in aerosolized air when passed through the heated filter. This invention was engineered and tested at the Texas Center for Superconductivity at the University of Houston in collaboration with the Texas A&M Engineering Experiment Station team. This scientifically proven air disinfection system using heat, UVC, and HEPA technologies that enhance existing HVAC filtration is safe, effective, and designed to be installed in home and commercial air conditioners and in mobile units, airplanes, mass transit, and public venues to provide clean air and sense of security to travel, work, be in the hospital, and return our children to school. At Integrated Viral Protection Solutions, we're eager to be a part of the solution.
This is a collaboration amongst the universities and parties you see here, the University of Houston Superconductivity Center, UTN, Texas A&M Engineering Station, and many more. Monza Hirani and IVP was recently awarded the top 5 technologies by the American Society of Mechanical Engineers across the globe for this invention. Engineering News Record announced Monza Hirani and IVP Air as the top 25 newsmakers, and on April 8th will be announced the Newsmaker of the Year at the award ceremony in Houston, Texas. This is a consortium or establishment of our mobile carts and what they look like. The larger V1, the middle is our R1, and the smaller is our T1. Dual utilization of systems have led to the analysis of a relative risk reduction of about 13.5% or 93% or 13.5-fold. In dual utilization of mobile carts, to the right is a mobile cart. In a square foot room of 1,000 square feet, 10 people in there, that mobile cart is working anywhere between 4 to 6 times per hour and 8 times per hour, compared to the ASHRAE standards of 2 times per hour. But it also has our special filter base embedded. On the left side is a heated filtration system inside of an HVAC. So we know that that virus can travel 26 feet and remain infectious for 16 hours. So when virus is getting pulled into that filter base, it can stick on that filter. Here's a quick overview of a relative risk reduction study with utilization of mobile carts by itself, adding on utilization of HVAC filters, and then combined with both for an average relative risk reduction of about 96%. And we'll get into the details here more. We're endorsed by Dr. Crabtree with the Argonne National Lab. This is our leading scientists and researchers across the country. I want to point out to you today a study that was published by the Nature article. We know that the CDC outlined and gave us direction that this is an airborne issue. The Nature study looks at filtration systems, particularly HEPA, and the lack of efficacy in the study where this airborne viral matter was passed from the first floor to the second floor to the third floor. The cellular structure is anywhere between 0.06 to 0.1. It's a sticky glycoprotein substance made up of and has RNA. So air blowing on this substance, if it's hanging on the filter, can make one into multiple to divide and re-enter into the room. This is not only about SARS-CoV-2, this is about our COVID-19. It could be about the next air biota threat that all of our partners said here today. And with our studies, we furthered this study looking at anthrax spores for future indoor air quality additives. To the left, I want to share with you a catching approach versus right, a catch and kill approach. On the catching approach, you can see all the filters we've used, MERV 11, 12, 13, 15, 16, and HEPA. And on the right, our catch and kill approach with IVP Air. With IVP Air's catch and kill approach, we do not reduce, absorb, or eliminate virus. If you look to the right, with our air biodefense on top, and on the bottom of that image is metal mesh foam. If you look at image B, we can mend and bend the metal mesh foam to an accordion style or similar to what a filter may look like. Looking at the C slide, that's a fluoroscopy image, and the next slide, which is D, that's the tiny porous membrane where we provide electrical heat. So standard filters today are in question of what has been done about, we know what our filters can do between 0.3 and 1.0. And when you look and review at the Nature study and what is happening with this particular virus and it traveling from additional floors, now in question becomes what is happening between 0.20 and 0.30 with filter bases. And so we know MERV 11, MERV 16, and HEPA, in the red squares, you can see they capture 95%. 99%. So when you look at the very bottom between 1 to 3 microns, 0.3 to 1.0, again, we're not reducing, we're not capturing 99% or eliminating. Our air biodefense filter has a functionality with embedding metal mesh inside of these new filter bases. The 3 attributes, if you look at number 2, act as a general filter or backstop alone with its very tiny porous membrane. It can heat and kill any sitting on porous metal membrane heat kill anything caught or sitting on the filter. So what we mean by if the porous membrane is also helping catch filtration, it's also heating and cooking, but the metal mesh also heats what anything is caught on the filter base that itself. So it's HEPA caught material, the metal mesh heats there. And relative to this point on C, in addition, the metal mesh creates a van der Waals effect. So our van der Waals effect pulls that ion material or that viral material into the metal mesh component and popping it, as you have seen on the initial video. This is the first time in history at the Galveston National Lab reporting complete elimination of SARS-CoV-2 and anthrax spores instantaneously in a single pass with no ozone or heat transfer. This is the largest public-private partnership conducted in the state of Texas, endorsed by MIT and Argonne National Lab with FDA approval. This is the Galveston National Lab where the Air Biodefense Lab exists. Initially, we killed 99.98%, then we increased 270-fold increase in SARS-CoV-2, and we achieved our 99.99% kill rate. We also ran an increase in anthrax of 4.5 and achieved the same. Then we took the studies to Texas A&M for temperature studies, understanding that anywhere between 89 and 200 degrees Celsius is the optimal temperature needed to kill this virus. Then we published our findings in the Materials Today Physics magazine and had over 2.5 billion impressions globally. Dr. Slobodan Pestler was instrumental in stopping the lab to perform these procedures, but more importantly, suggested that we study anthrax spores, because given the effectiveness of spores and the technology that this technology hopes for the next air biodefense threat, but also for the current threat of viral matter. So the fact that we killed anthrax spores gives us great hope for influenza, rhinovirus, measles, mumps, rubella, or anything in between that 0.02 to 0.30 that we continue to all look to investigate. Partners are also with the University of Superconductivity is Dr. Wu Chu, the founder of the Superconductivity Center, also Nobel Prize nominee. Dr. Ren, who's our Chief Scientific Officer, who's involved with our product development every day, and of course, Manzar Harani. As I alluded, Manzar Harani is a medical developer. He's very familiar with construction, anywhere between $6 to $8 billion in hospital portfolio. You see the skyscraper behind his head. He was developer of post-slab grade tension, so we can build skyscrapers as high as we can, but a physicist, structural architect, innovator, and engineer. We studied this outside of the lab, including post-acute medical hospitals, where we were able to show killing 100% of SARS-CoV-2 in patient room environments with our partnerships with other partners. But after 3 hours in the removal of the cartridges, we killed 100% of SARS-CoV-2. Here's a look at a 23-story high-rise with a filter bed of about a 16 filter bed system, but we replaced these filters with ours with the heated air biodefense filtration. This was conducted in California, where the highest, most stringent code would be, where you can see the highest, a lot of conduit there as well. This is a look at an install here in Houston, Texas, with the heated HEPA filtration base as well. The two ways that we treat are through mobile carts and then through retrofit HVAC. But the mobile carts, as everyone knows here today, is not only about an efficacy message, but a sense of security for students with a true efficacious message that we kill 100% SARS-CoV-2 and anthrax spores instantaneously in a single pass. So helping teachers want to return to school is our goal with air purification carts. We are in collaboration with the FAA and AAR in analysis of their current HEPA filters in replacement with our heated air biodefense for those filters as well. In collaboration with Texas A&M, we will be installing our air filtration systems into this first building. It's a $2.2 million square foot building in Houston, Texas Medical Center. Installing in University of Houston's Moore School of Music. We're installing in the George R. Brown Convention Center in Houston, Texas. We're partnering with restaurant societies to create awareness around air purification. We want to provide air purification systems in carts so that people know that they can come back to a safe environment, that we are doing something instantaneously front and center with these aggressive pushing and pulling of air with our air purification carts. We're working with the Department of Emergency Management and outfitting their bunkers. We're in collaboration with healthcare partners with Medical Properties Trust in 34 states and 6 European countries. With that said, I may be cutting it a little bit short, but I'll open it up for any additional questions.
Hey, Brian, super. Thank you very much. Yeah, we have a few questions that have come in. First couple of questions are both around the heating process. Someone asked if you're heating the HEPA filter up, you've increased the cooling loads. Do we have to remove that heat from the space? And is there any increased risk of fire with heating? It just says with the heat and kill system.
Great questions. No, there is no fire issues. Obviously, with the material, HEPA material or the filter material being fire retardant itself, but there's a proprietary pulsatile mechanism to where we're not blasting the total filter at one time. We know that the optimal temperature ranges are between 89 to 200 degrees Celsius, and the proprietary control mechanism ensures that there's constant heat, ample to create the van der Waals effect, but also heat to optimal temperatures to kill viral matter within that filter bed. I hope that answered the question.
Super. And one more question, Brian. The questions regarding the portable units, kind of a two-part question. One is what size room do the portable units handle? And the second one is regarding noise. How loud are the portable units? A common complaint of teachers is noise in classrooms.
So I'm sorry that my computer cut out on the first question, but I caught the second question of noise. And
the first question was in regard to how large of a space will portable units handle?
Thank you. The R1s range anywhere between 800 to 2,000 square feet relative to the number of people in the room. We can get involved aggressively with utilization of the Wells-Riley equation. The Wells-Riley equation, which was utilized in the measles pandemic, gives us a good calculus-based model and approach to that. But for the R1, that's the measurements there. On the larger unit, the V1, that's anywhere between 1,500 and 3,000 square feet. In relation to the sound noise, with each of the units, we have integrated a variable speed dial and variable switch that gives people the ability to pre-prepare the room and go aggressive with airflow or reduce and reduce for sound quality, and then also when people are in the room. So you have the ability to increase up and down, but decibel ranges are available at our ivpair.com website in the frequently asked questions sheet for each of those portable units.
Hey, Brian, one last question just came in. We'll make this the last one. Did IVP say it was FDA approved?
Yes, it is.
Can you expand on that a little bit?
We are FDA approved under the pandemic era and pandemic use. We are also in filings and extensions for additional FDA approvals, and that is taking place and has for the past 6 months.
Awesome. All right, Brian, thank you very much.
Thank you.
Okay, our last presenter today is Plasma Air. We have Dan Relihan, who is the Vice President of Commercial Sales at Plasma Air. I'll turn it over to Dan.
Thank you, Dave. And thank you to the rest of the presenters. I think you've done a fantastic job staying on time. I was hoping I'd be able to get a shot here as early as possible, and you guys were all right on time, so fantastic. Thank you very much. The bipolar ionization technology, you know, the one thing that is about this particular slide is I've left the heading the same as it was before the pandemic. Bipolar ionization technology for IAQ improvement, first cost, and ongoing energy savings. You know, same heading, and we talked about being able to use bipolar ionization as opposed to unipolar ionization, like in some ionization machines. Bipolar ionization acts completely differently. For instance, we have 4 different types of bipolar ionization techniques and technologies that we use on across our product line. So it's not a one-size-fits-all, but certainly there have been discussions about ionization in general throughout the years. You know, but the French were using corona discharge ionization 300 years ago, and it's been used in HVAC for decades. ASHRAE has recognized that our company started in 2007, but the founder of our company was doing ionization testing back in the early 2000s. And what you find out is that it has excellent efficacy results, therefore allowing you to reduce the amount of outside air in your spaces. So this was all a, you know, reduce your outside air, save on energy, save on first cost of your equipment. And it was, oh, by the way, it's an air purifier. Well, of course, fast forward to 2020, and the air purification component has become extremely beneficial, as well as, there's been a reference to third-party testing. From our company standpoint, we have done more third-party testing than any other bipolar ionization company out there, and we are solidly behind the results. And I'll share some of those with you as we go through. First thing I want to talk about is that with plasma air, you're really getting 3 technologies in one, and that's because plasma air, NanoStrike, and NuvaWave are all part of a company called Well Air. So Well Air is our parent company. 3 different technologies. We have 2 surface or 1 surface technology and 2 airborne technologies. Everybody talks about portables now. The portables that we have under our NanoStrike team product portfolio have been they're designed for medical grade uses. In fact, our 1050 is FDA cleared. There's a FDA question there. We are FDA cleared as a class 2 medical device on one of our portables. Excellent COVID testing. We have, of course, the plasma air solution, which is in duct as well as in space and in rooftop units and all that, basically HVAC type systems. And then our company purchased NuvaWave. A lot of UV technology out there. This is the first instant UV killing wand handheld device in the industry. And we'll talk just briefly about those 2, and then we'll get on to plasma air. As far as the Well Air platform regarding the NanoStrike portable units, NanoStrike is the technology that we used. It's not creating ions. It is actually, you heard a previous speaker talk about capture and kill. Well, we actually kill and capture. So we as the pathogens go across the NanoStrike technology, nano, just like it sounds like, quick acting, we're talking about seconds and not minutes of pathogen control, and that's the portables. Go ahead, next slide. The 1050 is a product, for instance, that is the FDA medical class 2 cleared. It has a HEPA filter in it, a pre-filter and a carbon filter, rated for 2,000 square feet, California Air Resource Board rated. Next slide. And now, one of the previous presenters talked about MS2 bacteriophage. We did a lot of testing with MS2 bacteriophage, and now that the COVID virus is actually available to test, just last week we got actual COVID strain 99.99 in 30 minutes when you put this in a space. So a lot of new technology coming along with the advent of killing the actual COVID strain. This is the first one in our series that we're going to do that. Still have a lot of great efficacy testing on MS2 bacteriophage as well. Again, these are all available on the Well Air website, but you can see it was really designed to go into a hospital room and kill everything in there, within a short period of time. So it's got excellent ratings across many different pathogens, specifically COVID, like we mentioned. 3 different brands, three different styles here: a 2,000 CFM, 2,000 square feet unit, a 900 square feet unit, and a 200 square feet unit, all California Air Resource Board rated. Then we have our new technology. Well Air purchased this NuvaWave on February 1st. It's the first of its kind, and it replaces any type of wipe down on surfaces that current practices are being done in the different buildings and schools and things like that we're seeing. It's 1 second. There's things in 2 and 3 and 4, but you get here a SARS-CoV-2 reduction 99.9 in 1 second, and then the more you have it on there, you get up to the disinfectant rate 99.99, the 4 log reduction. So it's an excellent handheld device available through your train company there. Again, you can look at the different pathogens. Obviously, we're all talking about SARS-CoV now. SARS-CoV-2. So contact your Dave and his team if we need more information. But the discussion here is going to turn now to the bipolar ionization, which is plasma air. I put this slide up because plasma air deactivates airborne viruses. As the previous one of the previous presenters mentioned, viruses are actually easier to kill than some mold and bacteria, but they travel quickly and spread quickly, et cetera. So you get excellent results with some of the legacy technologies, and even though ASHRAE calls bipolar ionization an emerging technology, there are some things that are emerging about it, like ozone-free options that weren't available back in the sharper image days. Ozone is a big concern for ASHRAE. They've been talking about that. Electronic air cleaners, with the caveat of having, you can certainly provide them, but let's watch out for ozone, right? So there's been a lot of that going on, and now what is emerging, like I said, is ozone-free types of products. But these two studies, real quickly, Dr. John Oxford in the 2017 Aerosol Science Journal, just a couple of them that talked about the MS2, the effectiveness of ionization on MS2 bacteriophage, which, we're all talking about SARS-CoV-2, but it was, very effective against SARS-CoV-1 and all the other acute respiratory, Middle Eastern respiratory syndrome, and also, obviously then would be effective against the less acute, the other 4 different types of coronaviruses out there. The blue box represents testing that we did prior to anybody even hearing about COVID-19. So we've been doing a lot of testing pre-pandemic, and again, Plasma Air, we lead the industry in our third-party efficacy testing. Next slide. One of the reasons why Plasma Air and bipolar ionization is effective is that there are a lot of different technologies out there. Bipolar ionization goes across a broad range of contaminants. It'll kill viruses, bacteria, and molds. It'll also take care of VOCs. It'll take care of your dust and your pollen and dander, gaseous chemicals, PM2.5, odors. You can accomplish these with a group of technologies, but from a bipolar ionization standpoint, the broad base of contaminants, that's an excellent choice to make because of that. So when you look at bipolar ionization, it really works on 2 different levels. The first one is agglomeration, and ASHRAE is actually, over the course of their webinars this summer, for instance, they really talked about the agglomeration, and that fits with the MERV 13 practices that they certainly talk about. The particles will get larger in the space with your ions. Your positive and negative ions will generate ion clusters, and these ion clusters will make the particles grow larger to size that now can be captured by a filter. The nice part about bipolar ionization is that we don't really care if you have a MERV 8 filter or a MERV 10 filter or a MERV 13 filter or a HEPA filter. It's going to make every filter work better because the particles are larger. And I think ASHRAE kind of wrapped their arms around, certainly around the agglomeration aspect of bipolar ionization. But just as important are the chemical reactions that are taking place to inhibit the growth of the mold and the viruses and bacteria, robbing the protein spikes and viruses of the life-sustaining hydrogen, breaking down VOCs into less harmful chemicals. This is the testing done with our third-party testing partners. They're all done without filters, so you're getting the chemical reactions that are taking place and reducing them dramatically. If you look at the particles, we've all talked about it in our slides, and here's one that just really kind of talks about the amount of particles that are in the space. So University of Minnesota study, if you look in the middle column, there are almost 20 million particles in the space. When we talk about MERV 13 filtration, as presented earlier, it's an excellent filter, plus 90%, 3 microns and above. So you get excellent results from a MERV 13 filter. And then it drops a little bit as you go to the 1 to 3 micron, and then you got both, of course, you got below 1 micron. But look at the number of particles in the middle: 50,000 plus 35,000 plus 1,000. So MERV 13 filter, you're getting 86,000 particles out of almost 20 million. And this is where bipolar ionization comes into play. As we all know, the coronavirus 0.1 to 0.15, 0.12. It's a very small particle, and it will get transmitted around the areas by attaching itself to other particles, things like that. But if you look at a human hair and you take a cross section of that human hair, 50 to 70 microns, there could be a cough or a sneeze, and you're generating 500 to 700 coronavirus particles in a human hair strand. So, you know, this is the world of ionization. It's taking those small particles and through purification and ionization, making the system certainly much healthier and safer. All right, so there's been a lot of talk about ASHRAE, and you know, I think ASHRAE, I'll say this, you know, with their April introduction of the infectious disease paper, I think they were probably neutral, negative on bipolar ionization, and I think a lot of that has to do with knowledge, the knowledge base. I think by the time these two webinars rolled around in the summer, I'm not going to say they were 100% in favor of bipolar ionization because they were calling it an emerging technology. But one of the things that they addressed was, you know, we like bipolar ionization. You know, when you listen to these speakers talk, as long as it's not creating ozone. So I bring that up again, as long as it's not creating ozone. But in a couple of these presentations over the summer, they specifically referenced the fact that there's, you know, ionization is an excellent option. They took some of the stuff off the website that they had. So, you know, we're going to continue to work with ASHRAE. There's now an ionization committee within ASHRAE to develop, you know, the standards. That's been one of the things that's been missing from bipolar ionization. There are a lot of testing requirements for, you know, filters and other things. There hasn't been a standard test for bipolar ionization. So ASHRAE is going to work with a group of experts from the bipolar ionization field and put that together. So anyway, ASHRAE is still going to present it as an emerging technology. But with our third-party testing, we feel very confident in its ability to perform as tested and expected. And one of the reasons that gives us some of this confidence is that, you know, independent testing is important. This was done by the Spanish government, completely independent. They selected a couple different technologies. They actually selected a little fan coil unit, that ionizer that we put on a fan coil unit. And they were having the doctors and nurses, they were going to convert a hospital to a hotel. A hotel to a hospital. So they wanted to get a hotel room, simulate a hospital space in there. They had a simulated patient in there, you know, the simulated equipment, turn the fan coil on, turn the fan coil on, do the test without the ionizer on, get the control, and then turn the ionizer on. And the bottom two bullets are the result of that. There was a 2-log reduction, 99%, in 10 minutes of the MS2 bacteriophage, which has been previously mentioned. So, you know, that's a good result. In 10 minutes, you're getting excellent reduction. Not only that, not only airborne, bipolar ionization typically isn't regarded as a surface technology, and I don't want to claim that it's a surface technology, but there was an 80% reduction in surface contamination, and that's really due to the fact that these, you know, when the positive and negative ions are in this space and the chemical reactions are taking place, what falls out of the breathing zone, if it's heavy enough to fall out through agglomeration, are non-toxic particles. So, it was a good result, primarily for airborne, but certainly surface as well. If you look at the product line, we do have products that are available to mount in a rooftop unit, in the ductwork, in an in-space unit like a VRF, PTAC, fan coil, water source heat pump, variable VRF product, these types of things. And so a wide range of them, ozone-free products. We lead the industry for the most ozone-free products, 2998 out there. And so we're going to continue to develop and continue to produce more products and more testing. But we also, through our parent company, again, have access to the portables. And again, portables, when you look at ASHRAE recommendations, we're going to do everything we can, you know, in the HVAC system to make it work and to purify the air. Sometimes we can't bring in the extra ventilation, of course, right? So, you know, having a portable unit is certainly acceptable, and Plasmare has those available to Dave and his team there at the San Francisco Train. We have a ceiling scrubber that has multiple layers of filtration in it, including a bipolar ionizer and a UV lamp and a charcoal filter. So, you know, we've got the air purification products that are not only flexible in their installation, but when you look at installing the HVAC components, there's no pressure drop associated with them, none. There's low cost to operate them. Any of the bipolar ionizers is about the cost of a low energy UV lamp to operate. So there's no extra electrical requirements. So they're excellent for retrofit with the no pressure drop. There's no extra fan horsepower needed. And then again, with the cost, the first cost, it's also, around the cost of what a low energy UV lamp is as well. So from a cost standpoint, very economical for the services that it provides. Now, so how do we know? 20 million particles, how do you measure them? I mean, there's all sorts of things out there, all sorts of IQ monitors, PM 2.5 monitors, TVOCs, et cetera, right? You can get any kind of monitoring you want these days. Well, we make ions, so we offer two ways to make sure that you're getting the ions that you want. We have a handheld ion meter. We have one, of course, that you can go to Google and you can buy them as well. We're measuring ions. That's what we want to do. And we have, if you get the value that you're looking for of ions in the space, that means you're going to get the air purification as tested. The other thing, another option that we have is to install a duct-mounted ion sensor. This acts like a thermostat. If you dial in the number of ions you want, and if it falls below that level for any number of reasons, it'll send a signal back to the building automation system that we're below the ions. If you do not get a signal, that means the ions are being produced at the level that you want them produced. So those are a couple ways from an ion standpoint that we're verifying that you're getting the ion density that you need to get the air purification. There's also numerous case studies, validation studies. If you take a look at the Plasmare website, there's full transparency, full documentation on how the protocols were set up, what the testing requirements were, what the pathogen that was being tested against. And so there's excellent information out there. And I think, again, as we get more of this information into the proper folks at other industries like ASHRAE, they'll see the merit there as well. So validation studies, case studies, ion meters, et cetera, everything to validate what we're talking about. So that's the wrap up here for me. I might have went a little over time, but I'll entertain questions now.
Super, Dan. Thank you very much. Yeah, two questions came in. The first one is regarding the portable units. Do the portable units use bipolar ionization or UV technology?
The portable units, it looked like a UV light there, the NanoStrike, but it's a tube, ionizing tube, because it will create ions, but it's actually a slightly different technology that utilizes a plasma field as opposed to generating ions in the pathogens. Unlike ions that are doing their work on the pathogens in the air, with the NanoStrike portables, it's actually killing it as it goes across and passes through the plasma field.
Super. And the last question, Dan, is in regard to the UL listing of your product. Can you expand on what the UL listing of your product covers? Sure.
So like the other companies here, all the applicable UL standards from a safety standpoint, the needlepoint ionizers are all UL 867 rated for since 2013, which is a 50 parts per billion standard for ozone. Plasmare led the way back in 2013 with products that created 1 part per billion. We were 3 years ahead of the curve with UL 2998, but now we have the products, the needlepoint products, UL 2998, which is 5 parts per billion ozone. And again, Plasmare has the most products available that meets that standard as well.
Fantastic. Thank you, Dan. Big thank you to all our presenters today, Duke, Dan, Brian, and Dan. Thank you very much. Brian, if we could, got one last bit of housekeeping here. We're going to send a quick follow-up survey. I promise you it'll be a very short survey. It'll take less than a minute to fill out. We're just looking for some feedback on what you thought about today's presentation, about the information that came out today. And in addition to that, what else you would like to see from Specialty AC Products San Francisco Train. A number of questions came in regarding control-related strategies, monitoring and management of air quality. And so Trane does have indoor air quality products, Aircuity and others. And so those will be listed in the survey. But in addition to that, if you've got any other topics that you'd like to see, we'll give you an opportunity to speak up on that survey. From an IAQ standpoint, I would like to point you to the PacificCoastTrane.com website. We've got a tremendous amount of resources on there and IAQ information. So if you're looking for more information, you can always go to PacificCoastTrane.com. And then within our controls group, Mark Warren is going to lead up the next webinar to talk about monitoring and control strategies. And then the last thing is, due to time constraints, we're pushing up on an hour and a half now. We were not able to get all of the questions answered today. So if you do have questions about anything you saw today, please reach out to your Trane sales engineer or your Trane existing building service sales engineer. And if you're not sure who your Trane contact is, please dial the number on the screen, the 408-481-3600 number, and our operator will put you in touch with the appropriate person. So again, thank you all for taking time out of your busy days and attending. Really appreciate it. And I hope to see everybody in person sometime soon. Thank you.